In this problem, we're trying to determine if a new form of CPR is better than an old form. And in order to do that, first you need to determine what conditions are met to actually do your testing. This is very similar to all the stuff that had to do with confidence intervals, in that you need to have a normal curve underlying your data in order for things to work. And the conditions that we check will depend on the test we're doing. Second part, we're going to look to actually perform the test, get a p-value, and determine if there is statistical significance to prove that one rate is better than the other. So in order to figure out A here, you need to kind of start with B. You need to figure out what test you're doing in order to figure out if your conditions are met. And the way that they did it here is they gave one treatment on even number days, one treatment on odd number days, and that'll be relevant in a moment. But in total, it says they treated 754 patients with one and 746 patients with the CPR versus the cardio pump. And in one study, 37 survived, and the other 15 survived each 1 year. So it looks like we have some number surviving out of some number of patients, some number surviving out of some number of patients. And what then we're looking at is a proportion. So given that, we're looking at a two-proportion test. So I'll write 2-prop down here just to remind us. Two-proportion test. And let's go ahead and pick one to be the first one. So you might pick the first one to be the 754. To be your first total, your N1, and then the 37 who survive would be the amount that survive would be your X1. And then again here in the second group, we'll call that N2, and the survivors, the number who survived X2. So 15 out of 746 in group 2, 37 out of 754 in group 1. So those are the numbers that we're going to use in the two-prop test. It says that it wants to know if the cardio pump results are significantly higher, so that will determine your null and alternative hypotheses. Remember, the null is always going to be that proportion 1 is equal to proportion 2, and the alternative, in this case, proportion 1 represents the cardio pump. I'm going to put C pump here just so we remember. And we think that that one's going to be better than the CPR. So it's always good to label these, because the 1 and 2 don't necessarily mean anything unless you give it labels. So once you have all this, you can put this into your calculator and do the test. But before we actually calculate that p-value, I want to go back to A and look at the conditions for inference. In order to do a two-proportion test, there's some special conditions that need to be met. We need to have at least 5 successes and 5 failures in each group. So make sure that you're looking for at least 5 successes and 5 failures in each group. Well, we have 37 successes here, so that's plenty more than 5. And then out of 754 patients, so there's plenty of failures. Over here, 15 successes is more than 10, and out of 746, again, plenty of failures. So this condition here, the 5 successes and 5 failures for each group, is met. So that's one major condition we have to check. The other thing, and that's what helps prove that it's normal when we're dealing with proportions. So you need to have this for normality with proportions. The other thing you need to check actually is related to statistical design, and in that case, we need to determine how the treatments were assigned. So going back up here, heart attack patients in participating cities were treated with either the cardio pump or CPR, depending on whether the individual's heart attack occurred on an even or odd numbered day of the month. Before the start of the study, a coin was tossed to determine which treatment was given on the even number days and which was given on the odd. So it seems that a coin was tossed. That's the randomness that determined which one is which. And there's a systematic approach. Every other day, they will treat with one or the other. And so that produces sufficient randomness within the study to say that patients are being randomly assigned to one treatment or the other. Now, this is not a traditional SRS or random assignment, but it is sufficiently random to consider it that way. So we would say that it is random because of the fact that they have the even number and odd number days, and then the coin flip to determine which one will get which treatment on those days. So that condition is also met. And then again, to do the two-prop test, just put that into your calculator.